Well, it's a pleasure to be here. I appreciate the opportunity to speak, and great to see so many folks in attendance. Just a quick background on Clearion, and I'm the co-founder and CEO. We are in our 15th year. We're based here in Atlanta, Georgia, in the U.S. And we started the company focused on utility vegetation management software, and that's what I'm going to talk about today. But we also provide vegetation roadside management software for transportation, road and rail, and also support asset inspection and maintenance management for utility infrastructure and transportation for blue sky operations, as well as storm and emergency response. So I want to talk about the components of a modern vegetation work management system as we've seen this evolve over the last 15 years. When we started the company, we were really focused on field data collection, work planning, unitization of work. That's grown enormously to support really all facets of utility vegetation management. So the components I want to touch on today are a management module to build schedules, do work assignment, dispatch work, both planned and reactive, field components to execute data collection and planning and notification stages, work completion and audits. Third is reporting for regulatory compliance, performance, safety, financials, and then kind of broadening out more recently into trends that we see is really sharing information across stakeholders within a utility, and regulators and other interested parties to look at status of work, emerging risks, emerging trends in what's happening in the field. And then finally, something I want to touch on that's been very exciting and much more recent is how utility vegetation management organizations can engage in the community to build collaboration opportunities, to look for ways to innovate and ways to give back to the communities in which they operate. So what we see utility companies looking for today is really comprehensive solution, what we hear people say as being end-to-end. So that's going to cover the planning, assignment, tracking, analysis of every component of your vegetation management program, from planned and preventative maintenance to storm response to customer response, customer initiated work, and other emergent issues. So I won't talk on all of these pieces here, but in both the office and the field, there's a wide range of tasks and information that need to be managed. The way that we come at this is we believe that vegetation management and other field maintenance activities are inherently a geospatial challenge and a geospatial solution. So everything that we do is built on a map. And we've chosen the Esri platform as really the basis for the GIS or mapping components of the system. And so I'm going to talk today about just what some of those tools look like before we get into some of the other innovations that we're seeing. So really the key to successfully addressing vegetation management with software is fusing all of the workflows across all stakeholders. So again, those could be your core workflows like preventative maintenance, the main work of keeping vegetation cleared from the power lines, whether distribution or transmission, and a variety of other workflows, and really getting the information that each person needs into their hands to easily collect and manage the data that they need. So for the office, we're looking at work assignment and management. So the components there are building patrol schedules, so sending people out ahead of work to do notification, permissioning, prescriptive work planning, or unitization of spans, and then taking that information and building that into work orders that can be dispatched out to crews or contractors, and then giving connectivity back from the field to really look at work progress, across all statuses, on a daily and monthly basis, and really comparing that against your annual plan and your annual goals from a work completion and budget standpoint. Managing your contractor personnel and contracted rates so that you can marry this up with financial systems. And then the way we've approached this is making the office-based module a native web application. So there's no installs to be done, and you get an instant access. Now in the field, the approach that we're seeing, and certainly the trend and the demand that we're seeing in the industry, is for field users to leverage really any device that they might have. So looking across Apple iOS, Google Android, and then Windows tablets, supporting the same user experience across all of those different platforms that provide tools for utility professionals that are doing work planning, the arborists, inspectors, notification staff. We were talking with a utility in Australia last night. They call it scoping. So the idea of people that are going out and assessing work either before it's completed and or after it's completed. And then in the same application, based on your user role, having specialized tools for contractor, crew leaders, and crew supervisors, what some people call general foremen, to be able to receive, complete, note exceptions, and then self-audit work before it's turned back over to the utilities for a final inspection. And because we're doing work around, in the case of utility vegetation management, around power lines, being natively integrated and aware of feeder configuration, corridor configuration, so that all work gets associated with the right operating record in terms of NERC type of compliance, and NERC compliance around transmission corridors and transmission lines, and other information, as you can see there, like land parcels. So with the support of the office and the field applications, we're able to produce a couple of types of information. We call the map-based, widget-based information that you see here a dashboard. So this is leveraging the Esri operations dashboard technology out of the box. So this is not something that we built, but the information becomes natively compatible. And you're able to see simple summaries of information, and then interactive with the map. So you can see on the map on the left, you've got tree trims that have been approved by the landowners, working through different statuses, trims, and removals. And then on the right, you see a heat map that really clusters, where the approved work is. And then we've got some other information around, how many man hours are projected that have been approved for work. So what's my backlog? And then looking at what's my average time per work site. And then, information down here about, the types of equipment that are being used. This is another example of a dashboard. So you can see we've got financial information. We've got total year-to-date man hours. Down on the right here, we've got reactive tickets coming in from customers, and we can see, some summary statistics there, planning and work completion. And then I'm able to drill down and look at individual feeders in this case. Here's another example of looking at work progress for a trim to standard. Now, the second type of reporting or business intelligence are leveraging more financial and statistical calculations. So you can see here we've got our expenditures by month, looking at budgetary targets, spend year to date, spend by vendor, and then we're able to, again, drill down into regions, filter out specific contractor companies, and even drill down to specific distribution circuits or transmission lines. This is another example of a dashboard report or a business intelligence report here that's looking at specific unit types and calculating automatically based on the information that's managed in the vegetation work management system to get average costs. And again, you can drill down by vendor, by contractor, by region, different types of classifications. One of the things that we've seen our customers look for is building forecast costs based on pre-planned work assessments. And again, that doesn't have to be tree by tree type of work assessments. It can be, less granular around more span-based work to spec type of contracting approach. But you can see here we've got the ability to look at total miles that have been scoped or planned, authorized, and then we're seeing from a unitization and a time and materials basis what our projected costs are. This is a more granular look at work by it's being grouped by work type. So we've got things like a bucket removal, a bucket trim, brush mowing, climbing. All of that's being unitized and associated with costs. And then we can also look at individual work orders or work groups that have been dispatched, and we can look at the accumulated cost as the contractors work through the assigned work. So I want to talk about data that's derived from remote sensing. And it's very common, especially for transmission organizations, to use LiDAR in support of this. But certainly in recent years, we've seen information that similar to LiDAR-derived vegetation points of interest that are coming from photogrammetry, from aircraft, and certainly more recently, as you'll hear later, from LiveEO. Information that's derived from imagery taken from commercial satellites, which is a really exciting development in the remote sensing technology. Our approach to LiDAR data or remote sense data in general is to enable our customers to innovate around what they do with that information. So, historically, you might fly a transmission line with LiDAR, look for radial clearances around the conductors, and then points of interest would be layered in. And maybe you would use a desktop patrol with 3D visualization on one screen and then the work planning tool on another. These can be dispatched to the field for ground truthing, or more recently, we've seen some customers exploring the use of logic based on the attributes of these points of interest derived from remote sensing data to actually automate prescriptions. So what that looks like in the field is displaying these tree crown polygons or vegetation areas relative to the overhead lines that they're around, and then being able to list those here to complete or assign or mark as needing rework, and then associating those with a distribution circuit or transmission corridor, and then also associating them with lines. So this is an example here that you see of a point of interest derived. That polygon is derived from aerial data sources, and then based on either automation rules that the utility determines, looking at the location relative to the line and maybe the height of what things need to be removed, or trees that need to be removed, or trees that need to be trimmed. So offering up a lot of flexibility here. We've also seen utility companies want to take this very granular data with tree crown polygons and then aggregate them to a span so that they can mark a span complete and saying all of the trees that were identified or brushes identified in that span are in bulk marked as done. And this is just another view of what it looks like with the very high quality orthophotography that can come. So I want to pivot over to some discussions really around the intersection of field operations, utility operations, and sustainability initiatives. We've been very involved in a number of initiatives, both in the industry generally and with specific customers that have come to us with ideas that they wanted to seek to implement. And there's some really great things that are going on that help both environmental initiatives as well as more community-facing initiatives. And this is a more general trend where we're hearing in industries, not just in the utility industry, but across the whole corporate environment that utilities and of course DOTs and rail companies and other infrastructure companies are involved, is this idea of the triple bottom line of process, people, and planet. So I think that the work management software that's getting information not just about work that needs to be done, but about safety concerns that might be out there in the field. Those are being addressed by the core, work management concepts. But this third piece of planet, this is where we're finding some really powerful new initiatives coming in to utilities, and they're leveraging work management and GIS technologies to really make those come to life and become more easily implemented and managed. So I'm just going to run over a few things that we're seeing. A lot of you may have heard of the Endangered Species Act impact around the monarch butterfly that looks likely to be coming down the road to affect any corridor management agencies, whether you're electric utility, a pipeline, a department or agency of transportation, a rail company, where the potential listing or likely listing of the monarch butterfly as an endangered and threatened species could really curtail our ability to do the kind of work that we need to do to ensure safety and reliability of our grid and transportation networks. So the University of Illinois at Chicago has built a Esri-based pollinator geodatabase, and you can go to that URL and learn about it. But we're enabling our customers to, in the same application that they use for their day-to-day maintenance work, to also inventory and observe and manage these habitat areas to hopefully restore the pollinator habitat, specifically the monarchs. And so this is a really important and exciting. It's an important challenge and exciting opportunity to leverage field data collection to document where your pollinator habitats are being built and maintained, so that you can contribute and have the assurances down the road that you'll be able to continue to do your vital maintenance work on these rights of way while still preserving important habitat, and also being able to integrate that habitat data with your work management data, so your contractor crews are not doing mowing or spraying or otherwise disturbing the habitat that you're developing. Just want to do a quick time check here. Another thing that we've seen that's been very close to home for us is working with Georgia Power to route wood chips to community organizations that need it. And it started out with a community farming organization in Atlanta, where they're doing education for school kids on agriculture and ecology, and also routing the food that's produced to families in need. One of the farms that Georgia Power is supporting through the wood chip donation program, that's all coordinated through their vegetation management system is actually for a prison transition facility for women that are coming out of the Atlanta prison system. So it's a way for Georgia Power to find local, close places to dump their wood chips that are actually hard to come by and take a lot of time for these organizations to obtain. And it's a very important part. I've hauled a lot of wood chips personally, and they go through a lot of them. And this has been a real win-win for Georgia Power and the community. Another thing that we're excited about, and we work with a number of our customers on, is tree replacement partnerships. So a lot of times we have targeted removal programs within utility rights of way, and we're seeing innovative utility companies partnering with nurseries, and in this case, we've got a canopy preservation organization in Atlanta that's planted about 140,000 trees in the last 20 years, and trying to really look at right tree, right place approach, planting, returning low growth trees underneath power lines, and also there's an opportunity to negotiate a removal with the promise of a replacement tree. And Trees Atlanta has the problem of we're looking to find places where we can plant trees that are wanted, and utility companies often can give those trees. And if you have a partnership with a nonprofit canopy preservation organization, you can really reduce the cost and support the mission of both organizations. As we got into the wood chip donation program with Georgia Power, they approached us about a program that they'd already developed with the Atlanta Zoo, or Zoo Atlanta, where the nutritionist at the zoo was looking for large volumes of specific vegetation to feed to their animals. So Georgia Power agreed to have the zoo go out in front of their tree trimming crews in the Atlanta area and identify species that they wanted left, and then they would be piled up, at the property and then collected by the zoo. So that's a zoo truck there, and a young woman who's in charge of this program is going around and collecting. And this was a very difficult thing to do at volume for both the zoo staff and Georgia Power staff. Any vegetation that got left on a property for too long, it would not be edible for the animals, but also would create problems with the customers who were wondering why brush vegetation was left in their yard. So we automated this process. The zoo was just using off-the-shelf software from Esri, and they're able to communicate in real time with the planners and the contractor crews to ensure that they knew where vegetation was on a daily basis, and that they could communicate back to Georgia Power that it had been picked up and each of the work sites was clean. And this vegetation is being routed to species of animals called browsers who need a wide variety of vegetation in order to optimize their nutrition. And it's something we've seen firsthand, and it's really awesome. If you have a zoo in your service area, we'd love to chat with you about it. This is some philanthropy that we're doing for any zoo that's interested. So that's everything I had to prepare. I hope it was a good overview of both the kind of the hardcore logistics and maintenance operations that's happening, connecting very complicated work processes across a diverse set of stakeholders, from leadership to utility vegetation management staff to contractor community, and then how we can leverage these tools to really innovate and support the environment and give back to the community. Joe?
Thank you, Chris. Thank you very much. Very interesting talk. And if you can answer a few questions because we've had quite a few. I don't know how much time we'll have to get to all of them. Let me start by asking, the focus here was on vegetation, but really couldn't you, and I'm putting words in your mouth, but couldn't you use your system to manage an asset, linear or not, for other issues as well? I'm thinking about erosion, for example.
Yeah, absolutely. We did target, we started the company to focus on utility vegetation management, but actually because utilities have such a wide range of processes, contracting methods, local regulatory requirements, we had to make it very flexible. And so, yeah, we're helping with asset inspection and maintenance. And then there's all manner of not just vegetation control, but other types of, environmental maintenance. Erosion control is one. We help our customers, manage their, culverts and gates and access points. So it is the concept of having a native geospatial, work planning and work management system can be applied much more widely across different types of work.
Thank you. So you mentioned in the description of your company this thing about bring your own device. So utility companies obviously use a lot of contractors, so we have a lot of players. How complicated is this? Can utility companies really support a bring your own device policy for contractors? And how difficult is it in terms of uptake, introducing them to these systems? And also, what are the security implications?
Yeah, we're definitely deep in the weeds on all these kind of questions. And the answer for bring your own device, BYOD, is absolutely yes. We've got customers that have been very successful with that. Being able to deploy the software through the public app stores is one solution. But oftentimes utility companies want to also deploy through their own private app stores and leverage mobile device management, and that really comes down to the security piece, and there's security built throughout the entire stack. Everything's secured. I think there's a question here is, can anyone access this information? Is by default no. You do have the ability to make certain layers public, but everything by default is locked down, on an individual user basis and then shared out by roles and groups. And then there's security around, not technology that we built, but mobile device management technology that gets the software onto approved devices. You manage your user logins yourself, so you can grant and revoke permission to access the data at any time. And then there's an additional layer of separating data out based on your role. So if you're a contractor user, you may be able to see and manage only a few pieces of information in the system, relative to what a utility planner can do. And of course, we separate all contractor data out. So the security is complex, and it's something that being in the utility industry, especially working with transmission organizations that are deemed critical infrastructure and adhering to NERC we've done a lot of work to ensure security.
Okay, thank you. So there's a question here from John. I'm not sure you can answer this. It may be more for a utility, but what are the temporal revisit schedules for the acquisition of LiDAR for these utility networks with respect to vegetation presence in the right-of-way and annual growth? And what are the costs associated? Am I correct?
That's a great question. I can probably only give a partial answer there, and maybe some of the other presenters can speak to the cost and the frequency. What I can say from a frequency standpoint is, we have customers that are doing trims on protected palm species where they're visiting that every year. And whether it's remote sense data or more traditional approaches to work identification, we have cycle automation built in, so you can set up a trim on a tree or a span that automatically recurs every 3 months or whatever frequency. But yeah, I think in terms of best practices around use of remote sensing and cost, probably need to defer to another somebody that's got more direct expertise there.
Aaron asks, is your platform based on field maps, Survey 123, or is it custom application?
Yeah, so we built our own software. The field application is actually built with the same development tools as field maps and Survey 123. So it is a native Esri application, but if you go to the App Store, it's Clearion. But it is it's compatible. So you might have seen the zoo, the people at the zoo are they're not using our software, they're using Esri field maps, but it's reading and writing the same data. And then just quickly touch on the web portion. So we're using either ArcGIS Online or Esri Enterprise for managing securing the data that's coming over the web and managing users and groups. The web application that we built, just to get technical for a minute, to answer the question, is it's a JavaScript API provided by Esri. So again, it's our own software tailored specifically for work management that integrates with our field app. It is compatible with ArcGIS Online and ArcGIS Enterprise on-prem, but it's a JavaScript API web application. Okay,
so 2 quick questions because we're actually out of time, but I'm going to ask these anyway because to me they're interesting. One is, how do you handle tree species classification, and do you predict growth over time to prescribe trimming and removal?
Yeah, that's a great question. I was laughing with somebody recently because I gave a presentation in early 2007 to tell one of the big tree vegetation management contractor vendors what we're going to do. And my thing I was most excited about was tree growth forecasting. And they said, good luck with that. It's really the only thing that we haven't gotten into. We found that others are more expert in that. Of course, our customers can inventory trees with species and any information they want, visually looking at it as an arborist. But the automated classification of trees from remote sense data, and potentially hyperspectral imagery, and I think even applying artificial intelligence is something that we see as being a consumer of on behalf of our customers, and we're not really working on that problem.
All right. So the last question, we'll have to let the others go for now, is the web portion based on AGOL, or is it an on-premise enterprise system?
Yeah, I actually did. I just touched on that one. I think we covered that off with my reference to the JavaScript API from Esri.
You might want. Okay, thank you.
And I can type some answers to anybody that asked a question that we didn't get to. I'll go offline and I'll type up some answers.
Yeah, I was going to ask you if you could do that, if you can stay with us and also come to the live discussion.
Absolutely. Thank you, Joe. Thanks, everybody.
Thank you.
Appreciate the time today.